Hi, everyone. Welcome to Legends of LambdaConf. This is our second episode, so we're really excited to welcome Shivay Lamba with his talk titled Decoding Search for Developers, Understanding Full Text, Semantic, Vector, and Hybrid Approaches. So we're really excited to have you here, Shivay. Thank you again for taking the time, and I'll hand it over to you.
Absolutely. And first of all, thank you everyone for joining in on a weekday. I know that a lot of folks might be coming in on a working day, and taking out the time, especially for that, is really awesome. I'm based in India, so it's almost 9:30 in the night for me. So I have the liberty to today organize a session, but would love to know from everyone. Where are you joining in from? So I'll begin. I'm currently in Bangalore in New Delhi, in India, and I'm originally from New Delhi, but would love to know from everyone. And what I'll try to also do is that we'll try to keep this webinar really friendly for everyone to chat. So feel free to ask whatsoever question that you might have at any given point. We'll keep it very interactive because I know that, of course, we are going to be covering a lot of deep technical concepts filled with a few demos as well. And I hope that at the end of today's session, everyone is able to take away this as a learning. Perfect. So we have Patrick from Germany. Hallo, ich bin Shivay. Ich komme aus New Delhi. Ich wohne in Bangalore. Ich bin 8 und, no, 6 und 20 Jahre alt. So, yeah, no, I know a bit of German. Marco from Croatia, Sacramento, and then Boston. Amazing. So we have like people from all over the world. Budapest. Budapest is one of my favorite countries that I want to visit personally. I've never gotten a chance to visit Budapest, but really awesome. We have literally like every single person is from a different country, which is crazy. And I know that when you are part of a community like the folks at LambdaConf, I mean, huge shout out to them for organizing the LambdaConf. I could not be there in person when it was organized this year. Rocky Mountains is one of my dream destinations to be at. So I got a chance to present locally, virtually. So I'm super excited to, be part of today's session. And I hope that at towards the end of the session, you're able to take away at least some of the other new learning. Now, I'm not sure how many of you have previously worked in the entire space of search. Would also love to know from everyone if all of you have interacted or worked, whether it's building some front end component or actually working on an entire end-to-end search engine itself, whether it could be Elasticsearch or an open source search engine like MongoDB Search. If any of you have actually built something along those lines, would love to know from all of you in the chat section as well. So that's to get an idea that what's the entire experience level of the audience when it comes to search. So would love to know what everyone has had experience with search. So if you don't mind sharing, as I will dive deeper into today's session, I will also share my personal experience with search and how I have gradually gone on to appreciate that how complex the entire search ecosystem is and how developer tooling really enables developers to build quickly and iterate over the search, right? So I will also just share some of my background with search, right? So I think Tim mentions next to none. That's all good, right? Because in today's session we will discuss more about that. So yeah, I mean, the audience members are sharing the superficially used Elasticsearch. So that's good to know, and again, my only request to everyone is let's try to make this super interactive. I know that we are going to be discussing a super technical concept. We will try to break it down into as simple conceptually as possible, but also, of course, keeping it technically enough so that all of you have something to take away from today's session. So without further ado, let's kick this off. And just, of course, one perhaps one thing to note is that my entire presentation today is very it has a lot of videos, it has a lot of influence from winter is coming. So if you understand the meaning of winter is coming, you will really be able to relate to whatever we discover today in today's presentation. So I wanted to keep it themed, and I chose that as a theme because the LambdaConf took place in the Rocky Mountains, which is very cold as well. Especially, it's a hiking and of course also a ice skating location. So snowboarding location. So I hope that you'll be able to relate to that. But without any further ado, let's get started. Now, a quick introduction about myself for those folks who have just started to join. I'm Shivay. I'm currently a developer evangelist, developer relations engineer at Couchbase. So Couchbase is a NoSQL database company, and I presented this year at LambdaConf virtually around the topic of how do you actually fine tune large language models. So I do come with experience both on the search side and on AI and machine learning research as well. In my previous role, I was at Miley Search, which is an open source search engine. And before that, I worked as a founding engineer at Dark Horse, which was a sports analytics company where one of my first projects was to build a search engine for being able to do searches for scouts. And that's something that I didn't, at that time, I didn't know about Elasticsearch or even some of the search engines out of the box search engines that existed in the market. And I had to build a search engine from scratch using tri-date structure. So that was in itself a huge engineering challenge that I had to kind of foresee. And while I was able to actually build it, I would not say that it was highly scalable. There are a lot of hacks that are involved into building that. But of course, today we'll learn conceptually around how search algorithms work, what are the different type of searches that are available for you to use, and how you can leverage a combination of something like a full text search, but also add AI capability, and how AI itself is really revolutionizing the entire search ecosystem with the introduction of vector search and hybrid search. So let's get started. Now, the first thing, of course, we have seen is that the entire web ecosystem has really evolved in the last 20 to 30 years, right? When we got to the year of 2000, the web was still in its early phases. Everything was super ugly and slow, right? As you see over here, this is the Microsoft website, and you see that it is not really very intuitive. There's a bunch of text, bunch of links, and when you navigate from one page to another, it is always going to be super slow. Now, when you went to 2010, you got to see a lot more of uh, high quality content, whether it was the introduction of the social media sites or the YouTube. But of course, when you were navigating or you were reloading a lot of the things, it used to actually take up a lot of time because we were not using caching. We were not, of course, at that time, even the APIs themselves were not that optimized. So to be able to retrieve results, it was taking up a lot of time. But ever since we have gone into 2020, mostly every website that you'll visit or web application that you'll visit is generally going to be pretty fast, powerful. There's tons of data that we are actually loading. So of course, as we see that the entire experience of using websites itself, right, or web applications has really grown in since the past 20 years. But what about the search experience, right? Sometimes you will see that there are websites that still kind of showcase this custom built-in Google search. And trust me, I have used this and I absolutely dread using it. I don't like the experience, and perhaps a lot of folks who are in this webinar right now will agree with me that you must have not had a good experience. Probably we can have a quick, vote. How many of you have absolutely hated using the inbuilt Google search that you might have seen in some, blog websites, or you might have come across this? Because of course, the kind of results that it gives is absolutely pathetic. Because let's say that you're in a blog and you're searching for a particular blog, and you then come across this custom inbuilt Google powered blog search engine, and then you search for something and you just get a random set of Google search results rather than being able to search for specific blogs that you are actually looking on a blog site. So I assume that a lot of you might not have had a good experience. So if you want to share some of your experiences, feel free to share it in the webinar chat. Would love to hear about your experiences as well. But in general, of course, if you're implementing a search out of the box, it can be very slow as well. Of course, at the time where we're looking at quick quick startup times for websites that are loading in next zero to time, right? We might see that sometimes if there is a lot of content, if you're trying to render a lot of content, it might not be that quick, it might be pretty slow. So how do we ensure that we are able to get very quick search results? Because of course it's a very well known fact at this point in time that if your audience is not able to see your website or the content on the website within the first few seconds, there's this huge drop off rate in terms of the website visitors. So you have to showcase your content across in as quick of a time as possible, and especially if you have a lot of content that's getting rendered by if it's been getting stored inside of a database and you're rendering it via API calls, it has to get rendered very quickly. And that is why if you were trying to just directly make a call to your database and fetching that as a result, right, it would generally be a lot more slower, but also at the same time it will be a lot more expensive, because just imagine that for every single call you're making a database call, and that ultimately adds up to the database calls, making it more expensive. It will require more amount of time because you are having to make API calls to your database. So all of that network bandwidth and having to fetch that will take up time. So that is why the search engines exist. We require search engines which essentially will not store all of your data from your database, but perhaps certain parts of it. And whenever you make a call and render or display something on your web application, you can actually make calls to these search engines rather than directly making a call to your database itself, in order to make your querying and your loading of your data a lot faster and also a lot more compute friendly for your database, and also for being able to actually render it in a lot more cost effective manner, because you're not making so many database calls. So that's an insight into what the common current search engine experiences kind of look like. But let's dive deeper. So of course, as I mentioned, that today's theme is going to be all about the winter is falling, so about Game of Thrones, but we'll use a lot of the references from there, right, in today's session. So hopefully you'll be able to follow along and also just have a bit of fun along the way. So of course, if we look at this particular text, is winter coming, right? This is such a huge trend when this is this is officially launched as a new series. And of course, you will now what you'll see is that search, whether it is in an e-commerce app or you will see it in any other website, right? Search is one of the topmost experiences that everyone essentially goes about, right? You will find a search experience in almost every single website, whether it's searching for your favorite item, or it's actually making a search for your favorite movie, right? Or you're doing a Wikipedia search for finding out your favorite article or the article that you're looking out for. This is something that we do almost on a daily basis, right? You will do a search to chat GPT, you will give it a prompt and you will do a search, or you will find your common contacts, or you will search for a common email from your Gmail. So everywhere there's an application of search. So of course, what does Jon Snow want to know, right, from this entire search experience? So you want to know that what the search will result when you have given it a query, when you have asked for a particular thing, it will of course respond with a query. So what will the search result? So of course, now if you look at how Google search kind of looks like, at one point in time, Google, using Google felt like magic. Now, of course, when you're going through Gmail, you're getting so many different junk mails, dodgy scams, and especially if you look at Google search results, you find just so many irrelevant search results at times, and it's like what should I do in order to make my search results a bit faster, a bit more relevant, right? Because sometimes you might scroll through tens and 20 different pages on Google search, and you might still not find the relevant kind of search that you're looking out for. So, of course, today what we're going to be covering is what really matters for you, like why search experience and building a stellar search experience as part of your application. Why should it matter, at least from an engineering perspective? And we'll also cover the different kinds of search types. So, whether it's keyword search, semantic search, vector search, and hybrid search. And vector search and hybrid search primarily because these are what you'll see as AI enabled search results or in AI enabled examples. And then we'll also see that when to actually use which type of search and some quick do's and do nots when implementing each of these search results. So let's first start with why does this actually matter for you, right? Now, of course, as I mentioned, that implementing a search functionality, right? And as someone from a management side, they might just say that, hey, it's a super simple implementation of just adding a search bar and boom, you're done with it, right? Now, management will not understand the technical complexities that is managed when it comes to adding a good functional search engine, right? And someone who has been on the forefront of having to build this from scratch, I can very comfortably say that the management has absolutely no idea at all, because building a search engine from scratch is a huge implementation aspect, because you are really parsing through so much amount of text. You're having to store it in a very efficient manner, similar to how if you were designing a database system on your own. So there's a lot of technical complexities that are involved in just the rough implementation itself, and there's a lot more when it comes to being able to optimize it, right? So of course, this is something that might come across when you are building an entire SaaS application, and of course search will always be an integral part. So, of course, it's not just about, hey, go ahead and build search functionality. There are a lot of other questions that you have to ask when designing a search system. It is, what are the performance requirements? What is the context of the search? What is this search going to be used for? What is the nature of the data that you're dealing with, right? It's not just as simple as that, okay, I've given you a JSON object data. Now just iterate over all of this data, search through all of this data, and give me the result. Your data could be in format of large SQL tables, all having millions of documents interconnected with each other. You could be asked to search from there. You could be given a set of images, and now you have to reverse engineer these images and find relevant image based on a text prompt. You have to find what's the closest image that matches this particular text prompt. And ultimately, like, what is the kind of problem are you trying to solve? Are you trying to make a very basic example of a search experience where you have a bunch of blog posts and you just have to search for the blogs on the basis of the blog title? But it could be as complex as having a Wikipedia, where Wikipedia, you're not only capable of being able to search on the basis of the Wikipedia article titles themselves, but you could technically search for something that exists from the body of the text, and you will be able to then ask that, okay, I'm searching for when was when was LambdaConf organized for the first time, and now it has the context to be able to also search from the body of each and every article, and not just based on the title of the article. So there are a lot of performance considerations. There are a lot of different uh, design thinking that goes behind being able to build a stellar search experience. And that is why it's important to keep in mind that we want to ensure that all of those are properly thought about before you actually build a search experience, right? It's not just go and build a search experience in a day or two, right? Build it ASAP. Because the management will not understand these technical considerations that go behind building a performant search experience. And I know that would love to know from everyone so far if you're able to follow along. I would just love to know, because I see that I've not really seen anyone respond after Marco. So if all of you are able to follow along If you feel the entire pace is good enough, please, if you can give me a thumbs up, that would be great. That will just let me know that yes, everyone is able to follow me along well. So if we can just have a quick vote, if everyone is able to hear me, perfect. All right. So, Tim, thank you so much, and I hope that everyone is able to agree with them. So, let's proceed further. So, these are the typical con- engineering efforts that are required in order to understand that how search works, and these questions will help you in order to implement a solution for your search. Now let's go about exploring the different types of search that we'll explore. The first one is a keyword search, right? So now let's look at the word is winter coming. Now it's basically broken into the words is winter coming. And the most basic way of being able to understand that what keyword search means is that you match the words in your query to the words in a set of documents. That, of course, you have your own corpus of data, and this could be an entire large PDF document, it could be a set of documents, it could be a set of JSON structures where you have some sort of textual data. And when we say that you're giving it a query, so for example, you're searching for a movie name, you're searching for let's say the Attack of the Titans, or you're searching for Shrek. So this is the given query that you're giving as the user input. And the keyword search would simply just try to find whether the words or the set of words that you've given in the query match somewhere in your document. So you'll do keyword to keyword matching, right? And of course, there are a bunch of algorithms that can be used over here, but it's as simple as just trying to find whether the given text in the query matches somewhere in your entire document or in your database. So essentially what goes on behind the scenes is that, let's say that the query that I'm giving as a user is winter coming. Now this query will get broken down through a process known as tokenization. The first step would be to break it down into individual words. So you get three different words as is, winter, and coming. So these are the three different words that you would break down your input query using the process of tokenization. Now, essentially, what will happen is that you would further break this down into is winter coming, and you will have a few other set of keywords trying to get extracted from this. And now, of course, what we'll try to find is relevant results, because what we are also trying to do is that for each of you know um, these keywords, we will find results from your data that are related to that. So, for example, winter could be winter clothing, because there might be a search or there might be a document in your entire database which stands for winter clothing. There could be another one for example, we have is winter coming. So there could be some other document inside of your database which says sales is coming, right? So you'll find a bunch of such kind of search results that match with parts of the corpus, that match with parts of your document, right? So of course, you'll not render all of these search results, right? So you'll get a bunch of different search results that match either partially. Because if you look at example of winter clothing, that is essentially a partial match, because it matched with one of the words winter, and then there was the sale is coming is also a partial match, because it is able to match with the word coming, but not with the entire text right now. But there might be certain instances of the documentation or your entire database where you might actually be able to find the entire search which is winter coming, and that directly matches with your given input. So we break it down into these individual tokens and first find that okay, if there is matches on a token level, and then we will further see that okay, we have found one match, can we find even further matches for our given input tokens, right? So essentially, as you see that how we actually implement keyword search in JavaScript. So your individual query will be broken or split into the individual words. Then what we will do is that we will basically calculate a relevance score based on the number of matching tokens in the document text. And then we will iterate over each and every document that we have, and we will calculate the score and filter out those documents with a score of 0, because what we essentially don't want is you will have the score of 0 when none of the input documents that you have given, that's the split from the query, when they do not match with the input from the documents, right, the document that you're searching on. Then you can just very easily say that because there is no match, you will just remove those parts, right? But of course there are parts where there will be the number of tokens that will match with each other. And then essentially what you'll do is that you would order the results by the relevance score in descending order. That means that if there are more number of matches based on the tokens, you'll get a higher relevance score. So for example, if there is a text within my entire document which says is winter coming, that will have the highest relevance score because it was able to match with 3 of the tokens. But if there is something like winter sale, here it will have a lower relevance score because only one token actually got matched, right? But if there are more number of tokens that get matched, it will have a higher relevance score. So this is what will find the most relevant search results. So here you can see this is a JavaScript function where we first send in a document and our query. So the const query tokens is basically being used to split our entire query into the different individual tokens. Then we have this function called calculate score, where again, for basically what we're doing is that for each, this is the loop that we are running, and if we'll see that okay, if the text tokens, so the text tokens are essentially we are basically splitting our entire text as well. So if they match with the query tokens, we will increase the score, and this way we will get to know across, as we will search through entire document, we'll be able to calculate the score, and find out what are the parts of the document which match the most with your given input query. I hope everyone is able to follow along with this particular logic. If there is any question, please do share in the chat, because this is like the basic thing that everyone will have to implement as you implement something like a full text search or a keyword search. So if anyone has any doubts, feel free to ask your questions in the chat. But if everyone is clear, even if you can quickly just share that yes, everything was clear, that'd be great. Would be great for feedback. All right, perfect. Thank you so much, Marco. Really appreciate that. And so that's a basic understanding of how the keyword search would basically work inside of JavaScript. You could implement it similarly in Python or in any other programming language as well. So of course, in this example, is winter coming? Let's say that we have a couple of documents. One is with the ID 1 with the text winter is coming to Westeros, and ID 2 winter clothing is coming. So the query is winter coming. With the search results, you will pass the query and the documents, and you will get the search results. So in this case, as you see that when you look at the result, you see that winter is coming to Westeros is actually on a higher level as compared to winter clothing sale is coming, because you also look at that how closely all of them are as well. So because both the documents had all the 3 tokens, so winter is and coming, right? But of course, when it comes to now, okay, finding which one is perhaps more relevant, when winter is coming is perhaps closer to each other as well, in that case, that might be given a higher preference. But in both these cases, you can see that the score was 3 because all 3 of the tokens were able to match. So they are rated the highest, right? So this way you just search and find whether individual tokens exist in your documents, and you make that particular find out. But if you had another ID with text as winter winter is harsh, so that would have given you a score of 2, and that would have come lower because we are now sorting that based on the descending order and how what is the score. So basically, the thing is that keyword search is great. It is effective for straightforward queries, but it will struggle with complex or nuanced searches. And what are the examples of nuanced searches? That, for example, I am trying to add some sort of semantic meaning to my search. I'm searching for, okay, I could search, one search example could be just Iron Man, right? That's a very straightforward keyword search. But I could, if I don't remember Iron Man and I remember I'm searching for a movie that has a red colored armor because I know that Iron Man wears a red colored armor. Now, a typical keyword search would just fail because it does not have any semantic meaning attached to it. But if I want to improve the developer experience, if I want the experience to be such that I want the users not just be able to do keyword matching, but I also want them to be able to do some sort of semantic meaning where I'm saying that, okay, I'm looking for a movie where the lead actor wears a red suit, iron suit. So it will know that it's Iron Man, right? So when your query will have either complex or nuanced searches, keyword search will basically fail at that point in time. So that is why where we will now go on to see what is semantic search, and later on we will jump into the entire world of AI search, which is super hot right now. So I'll definitely recommend everyone to stick behind at least till the end so that we can cover those parts of the session as well, because AI search, vector search, hybrid search are the things that are booming right now, and almost every startup, every company is implementing that, but we are gradually moving towards that. So let's understand the entire concept of semantic search. So again, we go back to the drawing board of is winter coming. Now, essentially, semantic search uses natural language processing. So, if you're not aware of what natural language processing is, it is a branch of AI where we essentially give some sort of text to an AI model. It converts that into, of course, AI understandable or a computer understandable language, and then it is able to interpret that, be able to do some sort of mathematics or compute on top of it, and then render a result. So a very good example are the AI voice assistants like Google Assistant or even Siri, where if you ask a question, of course, it's a computer ultimately, and it's still able to actually understand a human language. For example, I can ask it, "Hey Siri, buddy, how are you doing? And what's the weather like right now in New York?" And it is able to understand us, right? So it's not really a human behind these augmented reality or these virtual assistants, but they're still able to understand us. So being able to use natural language processing and context understanding to interpret the queries. So it's not just around, okay, I am asking a search. For example, the context understanding is very important in these virtual assistants, right? Because you ask a question that, hey, when was Joe Biden, or like we'll take a probably a non political example, when was golf introduced in the US? So it will give you a year, and you can say how many players played, right? Now, in a typical search result, it would have just failed because it would not have known the context that it's about golf. But keeping the historical context in mind, since the first question that we asked was about golf, now you can ask it even further questions. And this semantic search is typically used so much in side of the modern chat assistants, right? A lot of the different large language models, you ask a question to ChatGPT, the same question perhaps, and then you ask it a follow-up question. It knows that it is actually related to the prior question because it maintains that historical context. So it's all about being able to utilize large NLP and context understanding to interpret queries. So now, your query expansion for just the is winter coming could be is perhaps cold season arriving, is winter season approaching. Because when you say winter, contextually, things like cold season or winter season are similar to winter, and then coming, you could also ask the question in a similar way, arriving or approaching. So this essentially, if you're introducing the semantic search capability in your application, that just enables a much more improved developer experience, because now you're adding ways where you're not expecting the person or the user to have the to be able to you don't expect the user at the end to ask the question, is winter coming exact, because they could ask, is winter approaching, right? But if you're using just the full text search, it will fail because it wants direct match. But when you add semantic capability, now you're broadening what are the possible search questions that the user will ask, and that way you will be able to answer that. So the contextual understanding is really important. So when you look at the semantic analysis, right, you're trying to understand that what's happening in the given query, because there could be two different kinds of context. It could be seasonal context, that if you're asking is winter approaching, it could be related to for example, winter clothing sale is coming, because in that case it's the seasonal context, whereas winter is coming to Westeros will be a reference to Game of Thrones, because so the related concept about what query that you're giving, right, could be understood from two different perspectives. One is related to a TV show, and one is related to purchasing clothing items for winter. So that is the kind of context understanding that you can add to your search results to make it even more powerful. So essentially, what will happen, or how do you implement semantic search, let's say in JavaScript, is you would analyze the query to understand the intent, right, using NLP techniques, and you would expand that query with the related concepts, like what we saw over here. These are the kind of related concepts that are possible, right? And then you would basically not only calculate the relevant score based on the semantic similarity between the query and the documents. So, for example, we will look at that as an example. So here, now you're not just doing a keyword mapping, right? You are, for example, if you're searching for the query that you give is winter approaching, there could be references to comment. So that is actually semantically relevant based on the document, as compared to, let's say, summer is coming, right? So you will try to find what's the semantic similarity between the query and the documents, and you would go ahead and do this and iterate over each and every document, find out the semantic score, that how closely are your input query and the textual query that's given inside of the document related to each other. And you could always filter out documents with a score that is below a certain threshold level. So for instance, like let's say the input query that you're giving is, I'm looking for uh, polo t-shirts, right? So the query that I'm giving is looking for polo t-shirts. Now, for example, there could be documents which says US polo shirt, Ralph Lauren polo shirt, right? Those are directly related. But there could also still be a Ralph Lauren shirt. It does not necessarily say polo. So that could, have a lower semantic value, but it's still a shirt. But if you have a US polo pant, or you have a Tommy Hilfiger pant, that is perhaps not at all related to your search result. So you can define how much of that semantic value that you want to add to get more accurate results, or to get more number of results. So that's something that you can define, and then you can always then order the results based on the semantic relevance, right? So again, here you would have, like, let's say, a function which analyzes your query. So for example, it could be based on a list of synonyms that you might have, right? So a very basic non machine learning way of implementing it could be that for that particular given word, you maintain a large corpus of related words in a list. So for example, if the user is now searching for one of the synonyms, you have that list with you, and it knows that, yeah, they both are interlinked with each other, right? Another option could be to use a large language model, but of course, if you don't want to pay the cost associated with running a large language model, this is a very simple technique. But you could, of course, go very much more complex into having an entire very complex corpus of data, and how is it actually interrelated with each other, right? To give even more accuracy when it comes. So you'll have these synonyms, and you'll essentially just find out, okay, if there is any sort of semantic similarity between the word and the set of synonyms that you have. And finally, then this is where you see, when you're trying to compute the semantic similarity between the given text and your query analysis, you can filter based on that. Okay, if the semantic score is less than 0. 0.5, I would like to just skip it, and otherwise I'll proceed further. So this way you can order your results based on the semantic relevance in the descending order as well. So here is another example where you are giving is winter coming. The first text is the same. The second text is winter clothing is coming. So here, if you are trying to run semantic search, so the result over here is you get one for winter is coming to Westeros, because winter is coming, like all of that is there as well. But in the other case, in this, when you look at the winter clothing sale is coming, why the score is a bit lower is that now winter and is coming, like they are a bit more separate, right? So, and if you look at more from a semantic experience, right, if you look at more from the perspective of what's essentially happening on a semantic level, uh, is winter coming, is more relatable to the winter is coming to Westeros, because you're actually talking about the weather or the season. But at the same time, if you look at winter clothes sale is winter coming might not directly be related to a sale or winter clothing sale. So you can see that the relevance perhaps will be closer to the seasonal aspect versus like a sale aspect per se. But still, it is related to a sale because there are winter sales. So that's how you can now give a rating based on the semantic meaning of the query versus the search that you have. So basically, what we have come to understand is that semantic search will excel at understanding the context and intent that is associated with your queries. So essentially, making it very complex, effective for your more complex and nuanced searches, and just giving you just a broader corpus of data to actually deal with, right? So that's a very great example of how your search experience would look like. And now, let's talk about vector search. So before we jump into all of that, before we do that, we'll also give you a small understanding of vectors mean, right? And why is it relevant, or how is it actually relevant? So again, we'll come back to is winter coming. Now, what we'll understand is what vector search is first of all, right? Now, vectors first of all are, and before we jump into what vector search is, first let's understand what a vector is. Now, in a typical sense, and for that, let me also very quickly bring up this particular presentation just to give you a quick understanding of what a vector is, so that you have a better sense of what vector basically means. And for that, let me go ahead and open this up real quickly. So I'll just quickly show this to everyone. So let's present and share this tab. I hope, is everyone able to see my screen, by the way, around what is a vector? I just want to ensure that everyone is able to see my screen, because I just changed uh, the screen right now. Okay, perfect. All right, perfect. Thank you so much. So now first let's take a seat back and understand what a vector is. So a vector is essentially just a number, right? For example, it could be a lat and longitude vector for Paris. It could be a vector of three values describing the RGB value. So it essentially this is a set of numbers. It's an array of numbers that correspond to data, right? And in this case, these are a couple of examples, but it could be a lot more complex. For example, this array is a GPT value for Luke Skywalker joining forces with Jedi Knight, a cocky pilot, and a Wookiee. So the idea really is that a vector is essentially an n-dimensional array that has these numerical values that represent the real world features of anything, right? Because ultimately, like for example, if you're doing AI, we are doing any work with statistics, you always convert your input data into a mathematical format. For example, it could be images, which are essentially just a huge n-dimensional matrix, because images are made up of pixels, and pixels are represented as matrices. Or it could be text, so text are represented as word corpus that are again having certain semantic meaning. So these vectors are n-dimensional arrays which represent the real world features of the data in these numerical format. So that is why you can have these vectors in different flavors and formats, and then you can plot them. So here, like, are the three different examples. And now I'm trying to understand that what vector search is, right? So let's say that you have a bunch of vectors in your database, right? And you have a new vector that gets basically generated from a user input. How do we find the most relevant data based on uh, the current data, right? Based on the particular current data. So essentially, again, what would mean is that if there are two vectors that are near to each other, right, in this entire Cartesian plane, that would mean that their real world features are also actually matching with each other. Because if you say that, okay, I have basically taken a bunch of images of clothing items and I have converted them into the vectors. So there could be an image of a black polo shirt, and there could be a blue polo shirt, and then I have another image with, for which I've converted that into a vector for a leather jacket. So of course the vectors for the polo shirts will be a lot more closer to each other, because they physically represent matching features in real world, right? So vector search would basically find the distance between any two vectors, and if that distance between the two vectors is small enough, that means that the real world features of the data match closer to each other as compared to further apart. And we'll understand that why are we actually doing this, like why are we converting our data into these vectors. Of course that might be a question to a lot of folks, right? So we will also answer that particular question as well. So, for example, right, and we'll basically come back to the vector search part in a bit shortly. But let's go ahead and jump back into also understanding that why even care about vector search. So, as I mentioned, that we will represent these mathematical vectors that essentially capture the semantic relationship between queries and documents. As I mentioned, that these vectors are capable of trying to understand that how closely two things are related to each other, because that numerical value, that numerical vector represents the real world features of anything. So if you can find features that are closer to that particular feature that you are just running, you can find closely related results. And that's what search is all about, right? You want to find the closest set of results that exist as part of your data. So that is why we basically use vector search. So now, essentially, the process of actually doing that is that you would first generate the embeddings for your text. So embeddings are nothing but these n-dimensional vectors. So the first thing that you do is you take your input set of words, you generate the word embeddings. So these word embeddings are these n-dimensional arrays. Then you basically convert your query also and your documents into the vectors. So both your documents are going to be vectors, and your input query is also going to be a separate vector. And then you would basically, what you'll do is you would compute the cosine similarity. So cosine similarity is essentially a way of and I think that Bob Armstrong mentioned on the chat that the only data structure is COSI, is the list that the vectors in the word. Yes, exactly. So you're basically cosine similarity. We again try to find what are the nearest search results between the given query that you've given and the list of documents that that okay, semantically, what are the closest search results, right? And of course, embeddings, these are what are the numerical representations of the words or the phrases, and then vectors are just representing the numbers of they are representing the words or the phrases, right? And then you do the similarity scoring and you find the topmost search or the topmost relevant search results for yourself, and you end up getting the result. So in order to basically again implement vector search in your JavaScript, so you would have your query and your documents, you'll convert them into the vectors, you would calculate the relevance with the help of cosine similarity, you would again now go ahead and do this for each and every document, so you'll iterate over each and every document, and then you can always order the results based on the decreasing order of the relevance. So initially again you'll see that we have the vector search function where we would use the get vector to essentially convert the vector to convert your input text into the vector. Now of course this is just a placeholder way of being able to do it. There are actual machine learning models like AlexNet, like clip-based models, text embedder models, right? There are a bunch of models that will do text embeddings, that will also do image embeddings, right? So these are typically like dedicated embedding models that you will typically use in order to generate these embeddings. And once you have generated these embeddings, what you'll do is that you would pass them back to the vector search where you would have the query vector. And now what you will basically do is that you will pass this in comparison to your document text, find out the cosine similarity and the score, right? And in order to basically do the cosine similarity, here is the function. So you essentially do the dot product, right? So dot product is basically multiplying individual elements and then adding them all together, right? So you return that particular and then you normalize that data as well, and that's the cosine similarity to find the relevance between any two different points. And this way you get the results based on which has the highest matching score based on the vector search, and you'll be able to find the results. So here is another example. Here again we are leveraging that same cosine similarity compute, and we get the following result. So basically, as we see, right, that vector search is able to capture the semantic relationship essentially by taking all of your words or your phrases into this numerical uh, representation, and then you find from your documents what are the most nearest words or set of documents that are nearest based on your current context that you have set. So of course, now if you kind of ask me that what's the difference between the semantic search experience versus a vector search, so vector search is more more mathematically uh, you know uh, focused. That in case of semantic search capability, you had to maintain a list of search results or those synonyms separately. But if you don't want to necessarily do that, you just want to use that how mathematically things are related to each other. In that case, you would use a vector search. You'll not maintain a separate list or a separate array of synonyms in order to be able to do your semantic search for you, right? So this will allow you to do it in a much more compute uh, intensive or a more compute friendly way, if you're doing it this way. And of course, like again, the thing is between the two things. So semantic search is all about understanding the content and intent through natural language processing. So if you don't have, like, let's say, an AI model or an NLP model to be able to do that for you, you can always go back to vector search, where you are searching through mathematical similarity, that how closely are they mathematically related to each other on the Cartesian plane, right, using vectors. So that's the main difference between semantic and your vector search. So I hope that makes sense. Now let's finally jump into the hybrid search. Now, before we jump into it, I would like to probably take a break of like 5 minutes and take some time to answer any questions, because I know that we are 1 hour into the session. So would love to just answer any questions that all of you folks might have had. In case there are no questions, you can also type in the chat if overall you've been able to understand conceptually that how all of these different search basically works. That'd be really good to know. All right, perfect. Yeah, and you can use the Q&A tab. You can also chat. You can also chat uh, in the session. So yeah, I mean, up to you. You can ask the Q&A in the Q&A section, or if you want to ask a question in the chat as well, that's completely fine. All right. So doesn't look like that there are any questions. So that's great. Of course, I'll be sharing the link of my slides and some of the demos that I'll be showing you like later on. So that should be helpful for you. All right, perfect. So let's proceed further. Let's move towards hybrid search. Now, hybrid search, as the word suggests, it's essentially going to be a combination of multiple search approaches. And this is what we are really now seeing as the upcoming or the biggest upcoming trend in the entire ecosystem of AI search, which is being able to get the best of both the worlds from full text search or from the vector search or from semantic search, and being combine the results from both in order to get even more better search results, right? So that's the approach that we'll have. So again, is winter coming now? Hybrid search is essentially utilizing the keyword matching, semantic analysis, and vector search to provide you very precise, contextually relevant, and semantically similar search results. So basically, taking the best out of all of these different worlds of in these individual searches, and later on we will also understand that when to use which type of search result, when not to use which type of search result, or the search type, right? We'll understand those best practices later on. So it's important to understand this conceptually. So let's look at hybrid search, right? Now, what's the hybrid search process going to be looking like? So, of course, we will first do a keyword match. Based on the keyword match, now we will also generate the word embeddings, convert our query into the documents to vectors, do the compute the cosine similarity and similarity scoring that we did in the semantic search, right? And then also adding the contextual understanding and using all of those together to finally come up with the most accurate and the most uh, results that match the most, right? So use all of these different functionalities. So essentially, as you see that we are combining all the different kind of search results, we are then analyzing the query and all the related topics, and then we'll iterate over each and every document. We will calculate the hybrid relevance score, which is essentially a combination of all the three different type of searches that we did, and then we will again order the results based on the hybrid relevance. So in this case, we'll have a set of query tokens that will get converted into the vector, right? And so that is why we have the get vector score, and in order to get the similarity, we have the cosine similarity to find the similarity over here. And that is why, like, you'll see that we'll have the vector score, we'll have the keyword score based on how many keywords match, right? And then of course for semantic we'll have the semantic score as well. So that is why you'll see over here that for each of these three examples, you'll just merge together the results from all of them and find the final result. That is and I'll be showing you an example of that very soon, so that you see that how does it actually look like in production. When you have a production grade application, how would a hybrid search compare against a typical full text search, or a very simple example of a vector search. And here, like, again, doing that hybrid search, you would again find different search result, like the results, right? So as we see, right, that hybrid search essentially combines all of those primary three different types of search results and gives you the results. So of course the question arises, when to actually use which type of search. Now, before we actually do that, I would give you an example, and I'll share this link with everyone so that everyone is actually able to, try it out and see for yourself how the search results look like. So here's an example where we would basically see the different kind of search results. So we can do the search on the basis of just the full text search, and also on the basis of being able to do it. So for example, if I search for Iron Man, right? So Iron Man is pretty much a full text search that you can see that it searches directly for the specific keyword, and it is able to give us the results. And the topmost result was given because it matches directly with the title. But you can always configure it to be that, okay, if it is not in the title, then okay, can I search for the body as well? So that is why the second topmost result you see is Captain America Civil War, because that has the word Iron Man in the synopsis. So that is why it has a lower overall score as compared to the main result, because if you have a direct matching of the actual title, then it will have a higher relevance as compared to if it's matching in the synopsis, right? So that is why you see that you get these results as in a descending order. Now, if I do something like um, humanoid wearing a red metal suit, let's see if this actually works. So you see that it gives you like an example of the Iron Giant and Iron Man as well. So that's an example of being able to use the semantic search or the vector search, because in this case, from the semantic experience, what you saw was that I was able to get the semantic comparison, right? Because I am like, my input query is saying that it is a red metal suit, and we know that Iron Man actually wears a red metal suit. I could have said, person wearing a red colored short. So I think, um, I guess it might be Superman and wearing a cape, I guess. Wearing a cape. Let's see. So it first says Iron Man, then Watchmen. Perhaps again, we could have probably done a bit better job with our, or like, let's say if it's like Shrek, right? So if I search for Shrek, it will give you like um, the result. But if I'm saying as a green colored ogre, right? It should still probably give me Shrek. So that's another example of how you see, right, that you're seeing that example of a real world sample where you see, okay. And yeah, by the way, I see that Alexander has raised their hand. Yeah, feel free to ask your question, Alexander. By the way, if you're speaking, I'm not able to hear you. Oh, by mistake. Okay, okay, okay. That's all right. And so the goal is over here, right? If you want to see more number of search results, you can go ahead and enable the filters as well if you want some additional filters. So for example, you'll see over here that what are the set of results that you want. For example, if you want to add some additional search filters, so this is essentially getting into the full text search query, and you are adding additional filters which can be added overall to your data, right? So if we just kind of look at how this is essentially looking like, we can kind of look at from the perspective of what's actually happening behind the scenes. So over here you can see, right, that we have this approach. But if we go ahead and look at the actual hybrid search results itself, right? So you have the generate embeddings, where we are essentially using the OpenAI embeddings in order to generate the embeddings for our input text. So your input data will get converted into these input embeddings, and these embeddings will be used for the vector search. So initially what we are going to be doing is these are just some functions that connect to the Couchbase database. So we're not concerned about that. But let's talk more about how the search would basically work like. So the first thing that you'll see is, right, that we have our search embedding, right? So that will be used for generating the embeddings for our query and for our data as well. And then this is going to be our entire search query, right? So we have the vector search, for which we are passing the embedder, right? And then we also have some additional options. We are basically using by the default search, which is just strictly based on the search results that's already running in my locally in my system. And now I'm adding an additional vector store, right, which will be used to generate the vector search capability. And now you are essentially adding both your your scope as well as your embedding, so that you are able to get results from essentially both the vector search capability, right, that you just saw as an implementation, and as well as the full text search, because that is something that will still actually take place outside of the box. So that's a quick example of how this will essentially come into the fruition. um, so let's proceed further, right? Let's proceed further into our application. So let me go back to the presentation. So now let's understand that when should you actually use which type of search, right? So of course, keyword search, as I mentioned, it's pretty straightforward. When you have very straightforward queries, you want higher precision on exact matches, that your matches should directly match with what you're searching for. Uh, of course, that's going to be a simple implementation, and you'll have a lot lower compute cost associated with this, because you're not running any AI model, and you're not running any additional algorithms to find more relevant search results for you, right? So if you want to run your search on a lower compute cost, then you can go ahead with keyword search. For example, for this would be searching by SKU, because at a logistics company, when you are scanning a particular item and you want to find out the entire the itinerary, or sorry, the inventory of that particular item, you just want to very directly search that, okay, in your barcode scanner you found the SKU ID 12345, does that exist in my data or not, right? So it's very straightforward, simple example of searching by SKU. Semantic search, of course, would be, when to use it, that whenever your queries are having natural language rather than being very specific in nature, where, if you have a natural language, it will fail in the case of the typical search result. And then you are providing some sort of context and intent, and it's actually relevant to the kind of queries that you're actually sending, right? And you are able to actually handle these synonyms and the polysemy. So that's where you'll use semantic search. For example, it could be related to an FAQ, right? You are searching for a commonly frequently asked question. You are getting a lot of frequently asked questions, and people might ask it in different forms, right? In different ways. So you can leverage the semantic search capability to always redirect the user to a common answer based on whatever way in which they ask the question. If the semantic meaning of that particular question is the same. So this could be used in a QA chatbot, in a support chatbot, right? So that's an example. Now, when to use vector search? So of course, again, you are finding similar documents based on the similarity mathematically, right? And you are able to actually handle complex queries with such type of semantic relation. For example, it could be Netflix, right? So Netflix actually uses cosine similarity to find, that, okay, like currently you are watching, let's say, uh, an example could be, you're watching the Titanic, so it will give you relevant search results, that, okay, what are the set of movies that mathematically are clustered together with Titanic. So it could be some other melodramatic or adventurous movies, right? So it will give you results based on that. So that's an example of the Netflix. But ultimately, as we see, right, what might be the use case for a hybrid search, where you are not only having to balance the accuracy but also the balance computational cost. because it's going to be so much of work associated having to deal with all the different type of search results, right? So an example of that could be a true shopping experience, right? Because sometimes in an e-commerce site, you might search directly for a type of product that you already know the name of. For example, I know that I want to buy an iPhone, so I'll search for an iPhone. But let's say that you are not able to think of, okay, what's a laptop stand called, or what's that Google device that connects to my laptop, right? That connects to my laptop, and I'm able to render my screen. So in that case, right, I don't know the exact name, but I can describe that and I can purchase that item without still worrying about the music, right, or worrying about that particular item that I want to purchase. So an e-commerce application experience will be a great use case for a hybrid search, where I could also upload an image of the thing that I want to purchase, and I'll find that, okay, whether uh, that similar type of product actually exists inside the e-commerce store or not. So those are the kind of use cases, right? So just to kind of recap, when it comes to keyword search, you're specifically searching for document titles, product codes, right? Semantic search would be more focused towards customer support queries, FAQ search, ambiguous meaning, when there's not really a lot of semantic similarity between the data, right? So you want to provide that additional context that will be helpful, right? And that will ultimately help you to understand what are the do's and don'ts. So as we have come to kind of understood, right, that um, whenever implementing and of course we'll also now touch upon the five main things, right, that are important, that what are the major implementation tips when it comes, right? So one thing is that, okay, you have now decided that I'm going to be using vector search, I'm going to be using I'm going to be using just full text search. But then when it actually comes to implementing it in production in real life, what are some of the implementation tips, right? So what are the things that you should do and what are the things that you should not do? So for keyword search, you can actually use indexing for speedier search queries. So first of all, like, what exactly is indexing? So essentially, when and we'll basically discuss about indexing. So we'll essentially, what we'll do is that we'll start with indexing to speed up the search queries and making the system capable of being able to actually handle larger datasets effectively. So indexing your data can essentially significantly reduce the query time, which is of paramount importance, because no one wants a user to have to wait for more than a couple of seconds for a result to appear. And we should also make sure to sanitize our user input. So given that there are many popular web frameworks and libraries that automate the sanitization for you, it's not always a given, right? So it always takes one malicious actor to submit a drop database query in your search bar and destroy all of your valuable data. So depending on the language and framework that you're building with, there are numerous libraries that you can actually use in order to incorporate the user input sanitization quickly and painlessly. And so that's why, like, that's a really important thing that one should keep in mind when you are doing that. And then what exactly is the stemming and lemmatization, right? So let's kind of dive deeper into that. So essentially, the thing is that users often search in ways that you may not expect, right? So they might use some advanced searching techniques like stemming and lemmatization. So stemming, what that means is that stemming is a technique that will basically reduce the word into their root form, and they might strip away the prefixes and the suffixes. For example, the words running, runner, ran would all be reduced to the root word run. So this approach helps in basically matching user queries with relevant documents, even if the exact terms do not directly appear in the text. For example, I can say I was running in the park. So there might be a word run in the document, but with the help of the stemming technique, I will be able to find those words that are, of course, run and running are the same, right? They're just different verbs. So to its base or the dictionary form. For example, better would be lemmatized to good, which is the base form. And this technique will ultimately help you to improve the accuracy of the search results by finding variations of the word that are understood and matched appropriately. So let's say that you're building your application in Node.js and you want to incorporate these NLP techniques, right, for stemming into your search experience. So there are different types of Node packages, for example, Natural, which will be able to actually stem the results for you, right? So that's another important aspect of the search. And another thing to keep in mind is that as now we will talk more about the keyword search. So again, don't really just focus on the keyword search for complex queries, right? And then the thing is that you can ignore the stop words without considering the context, right? So that's something to keep in mind. And just always ensure that you don't overlook the user experience that's there with your current data. And always ensure that you neglect always ensure that for larger data sets, don't neglect the performance optimizations. Now, when it comes to semantic search, the things that you should always try to use a pre-trained large language model or an NLP model to understand the context. You should always use synonym recognition, right? So that you can find similar related words and still be able to give you accurate search results, right? So that's a really important thing. And then it's always important to evaluate your NLP models for relevance and for performance. If you feel that they're not giving you correct performance, then you can always go back. Because the thing is that when it comes to search, right, search can also be a very time consuming operation, because the compute time it actually takes to process a query can vary depending on how you actually structure your data. So if you're able to apply some sort of dimensional reduction techniques in such a way that you're able to reduce the amount of total data that you have, but still be able to actually do good search queries. Dimension will help you to improve your performance and compute cost by simplifying the data structure without sacrificing any information that is getting lost. So, for example, I'll share this particular article that does a really great job in explaining the different kinds of dimensional reduction that one should implement on their data in order to maximize the use of those, right? Because it not only helps you to speed up your search queries, but it overall helps improve the performance of your search as well, right? And ultimately, see, the users are always going to be at the center, right? One of the best ways to know that if your search is actually working well is that if you have some additional metadata using which you can capture, for example, it could be adding like a thumbs up or thumbs down request, or ask specifically from users feedback that did they like the search result, right? Because the most performance search implementations are worth nothing that if the users actually still reporting negative experiences, and it could just be that the way that you've implemented your search result. So those are some of the things that you should keep in mind when it comes to adding, like, what are some of the tips and do's and don'ts for managing your data. So these are the tips for the semantic search and in general for search. And of course, it's very important to not overlook the importance of context, because context is super important. I earlier gave the example that you're asking the first question as when was golf discovered in the US, and the second question that you ask it that who is the best player. But then if you're not maintaining the context, the query will not have any significance because it is related to the previous query. And then don't just solely rely on semantic search for highly specific queries, because it's not necessarily like it will always give you the correct response, because there might be always be some sort of ambiguity associated. And then of course, like vector search, you can utilize the dimension reduction to improve the performance. You can represent your text in a more effective vectorization technique in order to and then you can always regularly update your vectors with new data, because that gives you real world production use case of what your data looks like, right? And don't just rely on vector search for exact matches, you can always combine the full text search or the text search capability with this, because that gives you much better understanding of how you can actually use it. And then of course, for scalability, right, never ignore it, right, never ignore the scalability, because the thing is that as you'll have these such large dimensional vectors, you'll also have to store these vectors somewhere, right, and that can take up a lot of compute, that can take up a lot of storage. So ensure that you take scalability into account when it comes to vector data, right. So that's something to always keep in mind. And of course, hybrid search ultimately is going to be that, and of course, one thing that I didn't speak specifically when it comes to vector search. So see, traditional relational databases are not optimized to handling high dimensional vector data. So when implementing the search system, right, it's also very important to optimize your database, especially when you're working with vector representation of data, because as you know that vectors are powerful tools for being able to capture the semantic meaning of words and phrases. However, managing and querying vectors can be very tricky, right? So traditional relational databases are absolutely not optimized at all for handling these high dimensional vector data. So they will, of course, lead to even more significant performance bottlenecks. So you need to basically design a database that treat vectors as first class citizens that are built to handle that unique constraints and complexity of vectors. And these databases are basically built with the capacity to not only store and index the vector effectively, and they also provide optimized algorithms for being able to actually do semantic similarity or the semantic search, ensuring that the search results return quickly even as your dataset basically grows. So that is why like optimizing specialized vector database is really important, right, that can handle all of that. So with the vector search, that's one thing to keep in mind. And of course, like with the hybrid search, as I mentioned, that you essentially have to provide different sort of weight to the different technique, because every technique, like the full text search will bring its own search, bring its own results for you. The full text search and then the vector search will provide its own type of results for you. So sometimes it will be required to basically give certain weights, like do you want to give more weightage to full text search than to the vector search, or do you want to give equal weightage to all of the different search components, and then you basically combine the best techniques used in each of these different components and use that to demo, right. So that's one thing to basically keep in mind. uh, and before we jump into the final aspect of this, I would like to give you like a quick overview of how you can do the or just give you kind of the lay of the land of how today the entire search like aspect or search itself lies. So for that, I'll quickly stop sharing and I'll share my entire screen instead, right. So I'll share my entire screen, and I'll first start with some examples. So for instance, like you want to do a full text search, right? So for example, Miley search is an example of an open source search engine which you're actually able to use to very easily like just use their SDK and build a full text search capable app. You don't need to have a database. So here essentially you could take your data from JSON, or you could import your data from like let's say some other type of database, and then you'll be able to get. So for example, here you can search for space cadet, and it's like really quick. So this is an example of a full text search engine. They also like technically have the vector search capability, so they also call themselves as an AI search. But this perhaps might not scale that well. So that is where something like an Elasticsearch would actually perhaps be a better choice, because it's actually a distributed search. So if you have a lot of data, you can basically set up different clusters of your database of your search, and it will be able to always give you good results, because you can scale up your entire database and your search based on how many people are trying to make a search, right? So that scalability comes in the picture. So that is why like the Couchbase, which is my company, has its own full text search capability, right? So it has its own full text search capability. An example for which I just showed you. So basically, what the full text search would essentially do is that whenever you give a new input text, it would first do the matching. It will scan the indexes for either text or even like geospatial. For example, if you have data in the format of latitude and longitude, so if you have geospatial data, you could actually also then do the one-to-one mapping of your search based on that geospatial data, right? It could be based on images, it could be based on longitude, or even the vector embeddings, as we have kind of covered before. So that's an example of like how the full text search kind of looks like, and how today you're seeing that more and more companies are now not just shipping full text search, but they're also shipping, in addition to the full text search, they're also shipping additional things like the capability of the hybrid search, or the vector search, or the AI powered search, right? So it's not just being able to do your one-to-one direct mapping. You're also able to actually leverage AI search that will further enhance your overall user experience to find context aware search results, and not just like what you're directly searching for, right? In order to further improve your data. So, and again, I will quickly go ahead and share my slides. So, give me a second. So finally, at last, now I hope that all of you know what the different kind of searches are, how AI search is really taking over the world right now, with either the vector search or the semantic search capability to give you more sense and more connected search results, so that you can get better results based on the kind of queries that you might give, because you might not always give the actual correct matching query. So you should be able to get related search results, and that's what essentially getting powered by the different type of search results that you basically cover, right? And as you know, like, knowledge is power. So with that, I will conclude the session. But of course, I'll be more than happy to take up questions from all of you. And of course, what I'll make sure to do is I will also share my share the slide deck with everyone, so that everyone is able to kind of follow along. So let me also go ahead and do that. But I hope that everyone is able to follow along. Let me just go ahead and share this particular slide deck with everyone, so that everyone is able to, like, so let me go ahead and do that. If anyone can view. So this is the Canva link that I've just shared in the chat. But of course, one aspect that probably I didn't necessarily cover is, how to basically get started learning about search, right? Because let's say, from an engineering perspective, because like search algorithms themselves are, a lot of them are there. There's the Levenstein distance algorithm that are going to be associated, because of course, like, there are different type of search algorithms that are also there, based on whether you use them in a search engine or use that in a database, right? So there are a bunch of different type of search algorithms. So, and if we kind of look at what are the different type of algorithms, like, there is the linear search, there is like sentinel linear search, there is binary search, there is a ternary search, right? Fibonacci search. So again, at the core level, uh, that if you are trying to understand how searching would basically mean, because of course you would use searching for data retrieval, you'll use it in database systems for faster querying of your data, right? So fundamentally, you'll always have that target element, and you'll have a search space, and you'll also have the complexity, which basically means that there are different types of complexities depending on the type of data structure, or the type of search algorithm that you're using. And sometimes you might also have difference between your um, deterministic versus non-deterministic type of search algorithm. For example, something like a binary search is always going to be deterministic, whereas something like a linear search might be non-deterministic, right? So depending on of that, like, that's some more core CS consideration to keep in mind when it comes to search. But yeah, I hope at least from today's session, you're all able to get a more basic understanding of the lay of the land, and how search, what are the different search techniques and how you can utilize, and including the demos that I showed you. I will again make sure to also share the link of the GitHub repository that kind of does the hybrid search that has all the different techniques. So this is the GitHub repository that I showed you as part of the demo. And of course, if you want, folks, like, of course, I guess, Christina, like, we'll be having more of these sessions, right? So we can always, based on the feedback from the users, we can always dive deeper into a particular topic. Like, if, let's say, people are interested to learn and implement vector search from scratch, we can have just a hands-on session dedicated to building your first ever vector search enabled application. So if the users over here, like if the audience is actually keen in learning something like that, I'd be more than happy to always come back and have a much more deeper deep dive into just learning how to implement your first ever vector search or AI powered search application from scratch. And there we will dive much deeper into how do you get your input data, how do you vectorize it, how do you generate the embeddings, how do you store them, and how you can leverage all of that to finally build a production grade application. So we can definitely do that as well. So if the audience is interested, feel free to drop that in the chat if all of you are perhaps interested in that kind of a session. Yeah.
We have Marcus saying that implementing would be great.
Yeah, absolutely, Marco. So we can always discuss that offline, Christina, and see that if the audience is interested, we can always touch upon that.
Yeah, that sounds wonderful. You're always welcome. Your presentation was so engaging too. I appreciate the references, the GIFs, the
Oh yeah,
everything.
I just recently got into doing that because I felt that the audience is actually able to relate to the topic a lot more if you have a bit of styling and you have a theme attached to the presentation. So it's
Yeah.
always fun. Yeah, yeah. Are
No,
you also a GOT fan?
not particularly, but I did
Okay.
appreciate the branding. I haven't watched it, so
Oh, okay,
that's the
okay.
only reason why.
Got it, got it. And then I guess the reference would have probably been, but I chose the reference of his winter coming. That's, even if you're not a GOT fan, people would be able to understand that. And of course,
Yeah,
I
yeah.
mean, if you use a good efficient search, you'll get direct search result related to Game of Thrones. So that's where
Yeah.
you'll use a efficient search technique.
And it's pop culture at this point, so like the references
Yeah,
and everything are very timely.
exactly.
Um, but yeah, that was wonderful. Thank you so much for your time, Shiva. I really appreciate it. It seems like everyone's really happy with the presentation. Where can people find you or ask you any follow-up questions? I know you mentioned the
Exactly.
GitHub.
So I
Mm-hmm.
shared my Twitter, so you can definitely reach out to me on Twitter. I'm always active on the Discord as well. So I know that we have the is it the Discord, or is the LambdaConf Discord? I keep on
This,
forgetting.
it can be both, but I think it's more so the LambdaConf one.
Yeah, yeah, yeah. So yeah, feel free to reach out to me there. I'm always active over there. So I'll be more than happy to answer any questions related to technical side, or even if you just want to chat, I'll be more than happy to do that.
Fantastic. Well, thank you again so much for your time. And we will be concluding this session of Legends of LambdaConf. Thanks
Thank you
everyone
so
for
much.
joining.